Welcome to SmokeGuard's AIA Continuing Education series. Today's AIA course is titled Fire and Smoke Protection at Fire Service Access Elevators. This course has been approved for one learning unit for health, safety, and welfare with the American Institute of Architects. SmokeGuard is part of the Engineered Building Solutions Group, a segment of CSW Industrials. The EBS group unites Balco, Metacock, SmokeGuard, and Greco. These four leading brands provide innovative, safety-focused solutions for architects, building owners, engineers, and contractors with a shared commitment to life safety by design. SmokeGuard offers flexible, visually appealing fire and smoke protection systems designed to cover everything from small openings to large atrium spaces. SmokeGuard offers a full line of elevator smoke containment systems, including vertical, horizontal, and perimeter fire and smoke curtains, as well as shutter and static curtain solutions. SmokeGuard is a registered provider with the American Institute of Architects CES program. This course is approved and in compliance with AIA. This program is not intended to promote any specific construction material or method of use. At the completion of this video course, you will need to take our 10-question test and get 70% correct to receive your AIA Certificate of Completion. You will receive your certificate via email. If you are an AIA member and you provided your member number, we will report your course completion to AIA for credit. Please allow for up to 10 business days to report credit to AIA. This presentation is copyrighted by SmokeGuard. Any reproduction, distribution, display, or use is prohibited without written permission. In this section, we'll look at the key considerations for fire service access elevators. You'll learn their primary purpose in aiding firefighter operations, the specific design constraints and details that must be met, and the required separations and unique opening conditions that keep these spaces protected. We'll also review real-world examples, explore design options, and highlight common pitfalls to avoid during planning and construction. This presentation was pre-recorded by David Bauer. David is the Architectural Director for SmokeGuard. With that, let's turn it over to David.
All right, so we're going to talk about a niche topic here, fire and smoke protection at fire service access elevators. This is something that you don't always get into, but if you do, it can be tricky. It can be somewhat of an intellectual maze that you have to go through, and you got to get it right, and there are a lot of ways to get it wrong. So it's an important topic for a not super frequent application, but in bigger, taller buildings, we run into that a good bit. And SmokeGuard is part of Engineered Building Solutions, was a subset of CSW Industrials. And we have two sister companies, Balco and Greco, and we all work together in the marketplace. And 1 + 1 + 1 equals more than 3. SmokeGuard, we started out doing elevator smoke protection. We have expanded into vertical systems, perimeter systems, horizontal systems, and even static draft curtain type systems that we use in warehouses and hangars. But our stock and trade has always been the elevator. That's the majority of our work, but it extrapolates into a lot of other knowledge bases in buildings. Before we get too far into this is something we like to put in every one of our presentations because it's never completely understood. And we see a lot of notation, a lot of drawings that indicates that I'm not sure that they're really getting what they need to have in this case. There are 5 types of rated walls in buildings. And when I say rated, that can be smoke or fire or both. The big ones are firewalls that make your building into multiple buildings effectively. Fire barriers, as applied to this section that we're going to talk about, primarily defining shafts. Shaft construction is with fire barriers. Fire barriers can run anywhere from 1 to 4 hours. So there's a lot of variety in fire barriers, what they can be doing, but they are not smoke rated, but they are very robustly fire rated. Now we get into fire partitions and smoke barriers. And although on the surface, they look like they might be the same, fire barrier or fire partitions and smoke barriers are limited to 1 hour. They're only 1 hour systems. They are all fire rated, and they're all smoke rated. Now, the smoke rating doesn't mean too much until you get into the openings. Once you get into the openings, that is very meaningful. And there are even more nuances involved in those that are very critical to fire service access elevator lobbies. Smoke partitions are important to understand too. Even though they're not fire rated, they are smoke rated. Probably the most common application of smoke partitions is quarter walls in hospitals. construction of conventional elevator lobbies in sprinklered buildings. If your building is not sprinklered, even though we rarely do that anymore, then that lobby is required to be constrained with fire partitions. But smoke barriers are not as common, but they have a niche home. They're very important with regard to fire service access elevator lobbies, and they are critical in separating smoke compartments in hospitals. So you see those frequently. Now, as far as the openings go, openings in firewalls and fire barriers are heavily restrained. You only have the capacity to have a total width of 25% of the wall being open. And those could be windows, doors and windows, all doors, whatever combination. That can't add up to more than 25% of the overall wall. That's equally true in fire barriers as well. So that's a big restriction. It's coincidental that those are not smoke rated. I don't think that there's a relationship. But once you get down into unlimited openings in any of the other wall types, those are all smoke rated. One of the other concepts we want to talk about up front in this, we talked about fire rated walls. There are two others that are important to cover too. Multiple use fire assemblies is critical and lightly understood in buildings. And it's a very simple concept that once you get that in your head, it's very easy to deal with, even though the resultant construction that emanates from this can be rather complex. If you have multiple requirements placed upon one section of a building component, such as that wall and the black dashed line, and if there are two requirements landing on that portion of wall, such as in this case, there is a requirement for smoke-rated walls, shown in blue, and also the requirement for 2-hour fire-rated walls, shown in red. So the question that emanates from the multiple use fire assembly requirement is, what is the resultant requirement for that section of wall shown in the black dashed line? And the answer is that it's a 2-hour smoke rated wall. Multiple use fire assemblies require that if there are multiple requirements landing on one component of a building, that they are both in play. It's not a question of choosing one versus the other. It's not a question of which one is more restrictive or more demanding. It's simply both requirements. So that section in that black dashed line has to comply with all of the requirements for the blue walls, and also has to comply with all the requirements for the red walls as well. And that also becomes critically important in fire service access elevator lobbies. This is a splinter topic, but it's important if you're on a job site and you're trying to check and make sure that what you specified was actually constructed. Although y'all may not know this, I did not know this until just a couple of years ago when a fire protection engineer said casually to me, he said, "Dude, you know the label can be on top of the door." And I did not know that. So labels, door labels, are almost always in the spine of the door. But I discovered this through just one unique application where they did put this on top of the door. And sure enough, that is a valid way to do that. Now, these days, we all have phones in our back pockets. We pull out our phone, we take a picture of the label so we can see what it is. But this is a nice, convenient 6'8" door. 7 feet would be a little more challenging, but still doable. But what if you have an 8-foot door? Can you even see the label? But it is code compliant to put that label on top of the door. So just be aware of that. If you see a door that apparently is not labeled, it may be labeled. So fire service access elevators are a spin-off on normal elevator lobbies. This is a typical layout of a generic elevator lobby, and we're going to use a recurrent layout like this throughout a bunch of diagrams through the rest of the presentation. But normal elevator lobbies are constrained by smoke partitions. And anytime we show a wall in plan, we're going to show that little designation down in the lower left-hand corner so that we're reminded which one we're talking about. Again, in a conventional elevator lobby, it's enclosed, it's separated from the floor by smoke partitions. Smoke partitions are not fire rated, but they are smoke rated. And that's the requirement in a sprinklered building. And I mentioned quickly earlier that on those rare occasions in which we maybe are doing a renovation to a non-sprinklered building, that same requirement is in place. However, it would have to be a fire partition instead of a smoke partition. What that does is it adds that fire rating to that. There's a normal generic elevator lobby, and we want to start with these because we want to this will more clearly show the differences and distinctions to a fire service access elevator lobby. So this is a very typical elevator lobby. If you look at it carefully, you'll notice that it is non-compliant. And I won't give you the answer to that. I'll let you stew over that, but it is with regard to egress. If you look at the doors, you'll see that shortly. Another typical elevator lobby, this is one through which egress may pass, just like the other one. This one is also non-compliant for the same reason. And I'll leave that up to you to figure out what that is. But think about the direction of egress flow and the swing of the doors. So let's go to talk about firefighter operations for a moment. And this is the lead into fire service access elevators. And we want to understand, like I mentioned earlier, we want to know the why before we can talk about the what. So if you have a 4-story building and a fire breaks out on the 3rd floor, what does the fire department actually do? Well, they show up, first of all, and they do it quickly. And they'll go up the stairs. In this case, you're going from the 1st floor where they access the building into the stair and where they tie into the standpipe, and they go up and fight the fire. This is very straightforward. They'll go right up the stair. No big deal. It doesn't take them any time. So with respect to any elevator lobby or elevator types, not really relevant if they're fighting a fire on the 3rd floor. What if the building's a little bit taller, though? Well, they may still do the same thing, and they may not. It depends on the firefighters that are doing this. So each fire department is going to have their own protocol. In all of the dozens and dozens and dozens of firefighters I've spoken to, we'll see a range. I've seen a range from anywhere from 4 stories to 20 stories. So at and that distance is the point at which they will begin to use the elevator. So that's a wide range, but it's entirely up to them. It's their protocol, and it's their neck on the line, and it's their experience with their buildings in their city. So let's dive in, look a little bit deeper. So let's zoom in on that same 4-story fire, and we have standpipe in the corner of the stair. So the primary elements that we're looking at here is just the occupied floor on either side, extreme right, extreme left. Then we have the stair, and the standpipes in the stair. We're showing an elevator, and then between the two, we're showing a lobby. We won't get specific about what that is yet, but it's just a lobby at this point. So if we have a fire on the 3rd floor, how does the fire department access that? Just as we discussed a moment ago, they'll go up the stairs, tying into the standpipe at floor 2.5, and then they'll take the hoses up. Now they may do this 2 floors below. That's their decision to do that. Most fire departments are going to do 1 floor, but some may do 2. So what if we have a building that's significantly higher? This one's, and again, we're looking at, I think, an 18-story building in this case. What happens if we have a fire way up in that? I mean, think about, this is just a demonstration of how much more complex addressing a fire can be in a tall building. If they're using the stairs, what's going to happen? It's going to take a month and a half to get up there, and they're hauling up 80 pounds of gear. It's just not practical. So at some point, there has to be some way to help them out. And that way to help them out is fire service access elevators. So the fire service can come in, use the elevator to fight the fire, but we have to take different precautions, and there's different construction methods, design and construction methods in doing so. So let's look at that same example, but here we're talking about the 21st, 22nd, up to 24th floor. So in those cases, they would use the elevator, enter what we are going to call the fire service access elevator lobby, and then they're going to address the fire from there. So significantly faster. If we're in a 20-story building, it's immeasurably faster, and it's entirely their option to do so. In section 403.6, we're going to have the primary requirements for when you need to have fire service access elevators. Now, annoyingly, the IBC breaks it down into 2 different sections. One is where they talk about the requirement for fire service access elevators, and then elsewhere, they talk about the requirement for fire service access elevator lobbies, just to keep us turning pages. So in this section on the elevators themselves, the requirement for fire service access elevators, and we're going to sometimes shorthand the designation of these to FSAE. They're required in buildings with an occupied level greater than 120 feet above the lowest level of fire department vehicle access. Now think about the site. If it's a flat site, that makes it very simple. If it's not a flat site, it makes it more complex. It is the lowest level of fire department vehicular access. If you're in a steep city, Pittsburgh, Pennsylvania, San Francisco, California, Knoxville, Tennessee, that could be a 2-story, 3-story difference. where I went to college, at Carnegie Mellon, there was a building there that had a differential between the front door and the back door of 4 stories, and it wasn't a very deep building. So it can be a wide range, from the front to the back or from the high to the low point. You just need to keep that in mind that it's the lowest level of vehicular access. Then we're required by this section to put in 2 fire service access elevators. Those fire service access elevators just have to be able to handle a capacity of 3,500 pounds. Pretty straightforward with regard to the fire service access elevators, but less straightforward with regard to the lobby. The ICC puts convenient, handy diagrams in their commentaries, and they rarely put them in the code. But this is one of those cases where this is from the commentary, and it gives you a nice, convenient little diagram as to when you're required to have fire service access elevator lobbies. So anything from 120 feet on up. And remember that rooftop bars and restaurants are an occupied floor. So it's not just the highest floor, it could be the roof. Now we go to 3007.6. That section is going to tell you about what you have to do for the lobbies. This is not an exhaustive list. Go through the code and look at all the other things. There's some detail things that are, I don't want to say they're lesser issues. Details are always important, but these are the largest, the most earth-shaking of the requirements. So fire service access elevators have to open into a fire service access elevator lobby. That lobby is required to have direct access to an interior exit stairway. If you're not familiar with the term interior exit stairway, that's the IBC term for what we commonly call egress stairs, but it's your 2 primary, at least 2, sometimes 3 primary stairs out of the building. From that elevator lobby, the fire service access elevator lobby, direct access is required into that stair. There's a reason for it, and we'll talk about that in a moment. Those elevator lobbies are required to be separated from each floor by smoke barriers. Now, here we go, getting into smoke barriers. Smoke barriers, again, 1 hour fire rated and smoke rated walls. The reason that the code uses smoke barriers versus fire partitions, which ostensibly have the same requirement, they're application driven. So whereas fire partitions are in different applications, quarter walls in residential, things like that, smoke barriers are used in applications like this, to enclose fire service access elevator lobbies, but you may be more familiar with them as separating smoke compartments, hospitals, ambulatory care, other types of facilities like that. The doors are one of the key differences. Doors into the fire service access elevator are required to be openings and smoke barriers, and they have to have 45-minute UL10C, UL10B, or UL1780 and UL1784 tested. But that UL1784 testing, if you're not familiar with that, there's a variant on that. Basically, that's the equivalent of an S label. UL1784 can be tested with or without an artificial bottom seal. And if you're not familiar with that, it sounds ridiculous. And the first time I heard it, it sounded ridiculous to me too. And I assumed then that, well, if you can test it without an artificial bottom seal, then in theory, you must be able to test a system with an artificial bottom seal, which begs the question, what is that? And a potential answer, and actually, strangely, the most common answer is duct tape. So before a door is tested, it's permissible for that variant of a smoke rated test to first tape the undercut on a door, then test it under the UL 1784 test standard for a smoke rating. And if it passes based on the criteria in the code and in the test, then it's awarded an S label. I mentioned quickly, too, that door is required to be 45-minute UL10C, and I mentioned UL10B. UL10B is roughly an equivalent of UL10C. UL10C is for side hinge doors. UL10B is for overhead coiling steel doors. And then in the last 15 years or so, particularly in the last 5 or 6 or 7 years, we have fabric systems that comply with those listings as well. But this is the only location in the building in which there is a UL 1784 test required without an artificial bottom seal that is not immediately in front of an elevator. And this is also the only place where a UL 1784 tested without an artificial bottom seal is applied to a 45-minute door. So the lobby has to be 150 square feet minimum with no dimension less than 8 feet. That's pretty straightforward. And you have to have that little symbol there. There are some other requirements in there too. Probably the most important, and we'll look at some examples in a moment. When you put the standpipe in an interior exit stairway, which they always are, it is required to have direct access that does not pass through the elevator lobby. This is important because I'll show you an example of where this was not done. Keep that in the back of your mind, and when we get to that. And there are a couple other requirements too, mostly regarding sprinklers. This is an ultra generic layout of a fire service access elevator lobby. First thing we're going to talk about is egress through it, because it's one of the more important features. Then we're going to talk about ratings and some of the things. But this is the way the building occupants will use that lobby. They will not egress through the lobby unless they're coming out of the elevator into the lobby. If they're in the hallway, they'll go right into the stair, immediately into the stair. There's no point in going through anything else. You go right into the stair. If you look in the next building you're in that you see one of these, notice where the exit signs are, because there won't be an exit sign into the lobby from the hallway. There will only be an exit sign into the stair from the hallway. And then once you're inside the lobby, you may or may not have a sign in there. The sign is not required. The sign only, I believe the requirement is for an exit sign if there are greater than 10 occupants, and you're probably going to have about 2 or 3. But nonetheless, that is, whether with the signs there or not, that is your egress path from the lobby. But it's important to note, nobody is passing through that principal door into the lobby as part of their egress path. Now, the firefighters have to use this lobby as well. So what are they doing? Well, whatever floor it's on, if they choose to use that elevator, like I mentioned, they will stay just floor or 2 below the fire floor. They'll go in half level up or 1.5 levels up, as the case may be, access the standpipe, tie in their hoses, then go up the other half and then fight the fire through that door. This is something they will do every single time. They will never go out through the door from the lobby. And why is that? Well, the whole reason for the lobby is to give them a safe, protected bunker type of space. They'll set up a command post. They'll have their O2 bottles. They'll have a med station. The team leader will remain in that lobby, and then his crew will go up and fight the fire from the stairwell. But they will always fight the fire from the stairway. Again, the stairway is going to be 1 or 2 hour rated. But if we are talking about fire service access elevator lobbies, which kick in at 120 feet, although in theory it's possible for that to be a 3-story building, we know that stair shafts can be 2 hour or have to be 2 hour once you exceed 3 stories. So once you get to 4 stories or greater, they're always going to be 2 hours. So let's look a little bit more at those ratings. So back to the ratings of the shafts, they will be constructed as fire barriers. Fire barriers mean there's no smoke rating required, but there is a fire rating required. Again, in buildings in excess of 120 feet, we're talking about 2 hour shafts. So those 2 hour shafts will have 90-minute doors at the elevators. They'll have 90-minute doors into the other shafts. All these are doing is plugging the hole, basically, that is carved in there for the purpose of an opening. With a 2 hour shaft wall as a fire barrier, we have to put in a 90-minute door. It does not have to be smoke rated, but it does have to be fire rated. So this is what we're doing in both of these cases. And the requirement's the same in both. You may recall that there was a requirement to enclose the elevator lobby, not enclose it, but separate it from the floor with 1 hour smoke barriers. And it's redundant to say 1 hour smoke barriers. All smoke barriers are 1 hour. But that smoke barrier is fire and smoke rated at the same time. Openings. This is where you get into that 45-minute S-labeled door. It's not as simple as just a smoke rated door, even though it just says UL 1784. It's required that it be tested without an artificial bottom seal. That narrows down your choices significantly, because a regular old side hinge door is not going to cut it, because those are typically not, I say typically, I've never seen one that has been tested without an artificial bottom seal. You get into overhead systems and you get into integrated hardware doors, then you get into tested without an artificial bottom seal. So be very cautious. That's one of the most missed items that I see with regard to fire service access elevator lobbies is that testing has to be done without an artificial bottom seal. There is an option. The wording in the section 307.6 said that you have to have direct access into the stair. There's an exception underneath that. That exception says that you can go through an area referred to in the code as a protected path. And here's the language for the exception. Now, I don't usually like putting all the code language up here, but we'll do in this case because it's important to understand the language in here that they're using. One reason that it's important to read this language is that the last thing they refer to is that the door between the lobby and the entry into that protected path is required to be smoke and draft rated in accordance with section 716.2.2.1. Now, if you're familiar with that section, you'll remember that that section talks about fire rating, not a smoke rating. Now, there's a subset to it that requires a smoke rating, of course, and that's 716.2.2.1.1. However, they are saying that you're required to have a smoke and draft control assembly in accordance with the parent section, which requires a fire rating. It's a poorly coordinated language issue with the IBC, but it does introduce the fact that there's some ambiguities to what the requirement is. In my mind, it's easy enough to put in a smoke rated and fire rated door. It's probably the way to go, but it's an individual decision because there is that ambiguity with the language in the code. So let's look at this in practice. Here we have the same ratings for the shafts. And now we have to separate it from the floors with a smoke barrier. And that protected path vestibule type space in the upper left is part of the floor area. So we have that separation there with a smoke barrier. So already we know that wall portion separating the protected path is fire and smoke rated. This leads back to the previous language that's why I think that it needs to be a fire and smoke rated door. But that protected path has to have the same protection afforded to it as does the fire service access elevator lobby. So that protection is the same there. So looking at some of the doors. Now, this is where the 90-minute doors into the fire, through the fire barriers, into the stair or into the elevator, very straightforward, very common. We see them all the time. The 45-minute door we talked about a moment ago. That door into the protected path, this is where the question comes up. Is it 20-minute and UL 1784? The commentary in the code says that it's only smoke rated, but we have to acknowledge that it is an opening through a smoke barrier. So that is fire and smoke rated. So that's one of those things that you have to make a judgment on. Since the protected path is required to be afforded the same protection as is the fire service access elevator lobby, that door is also then required to be 45-minute UL 1784 tested without an artificial bottom seal. That's really important. Consider if that was not the case and you have smoke filling the corridor up on the top of that drawing. That smoke is going to eventually pretty quickly force its way into that protected path and then very quickly force its way into the elevator lobby through the next smoke rated door, which is not required to be tested without artificial bottom seal. So that outside perimeter is your defense line. If these firefighters are in that space for an hour fighting the fire, if they don't have that protection, smoke is going to get into that space. We're going to look at a couple of examples here. This is a fire service access elevator lobby in a hotel in Texas. And it's not uncommon, since we're dealing with the elevator core, that we have poured concrete walls that are acting as shear walls. This is why you have to kind of figure this stuff out and make sure you get it right early in the process. Because once we hand the project off to a structural engineer, he's going to take advantage of opportunities to put in shear walls. That's going to be it. And if we've articulated a doorway improperly, we're not stuck with it. But it's a lot more work to go ahead and get yourself out of that picture. But one thing to keep in mind here is if you look at that door into the stairway, and in this case, that does lead directly into the stairway. There's no exit sign over top of that. It is required for egressing people in this lobby, but it is not the primary egress path. So by not having an exit sign there, they're acknowledging that they have an occupancy of no more than 10. And if they had more than that, they'd have to have an egress sign over that as well. On the right, you can just see the end of a pair of doors. And in looking at those doors, I will tell you right now that those are not tested without an artificial bottom seal. So that, but they almost certainly are 45-minute. Again, that's something that's very critical to keep in mind. Here's a layout of that building. Again, the blue area indicates the fire service access elevator lobby. And we were standing on the left side of that, looking at the far side with the stair. This is where our exit path would lead us. Again, the one inside the lobby is not required. But notice that at the double doors leading into the fire service access elevator lobby, there's no exit sign. If you're coming down that hall looking for your exit as a building occupant, you're going directly to the stair, not through the lobby. I've mentioned that a couple times, but the question is why? The main reason is because it's so difficult to get a side hinge door that complies with the UL 1784 requirement for testing without an artificial bottom seal. It's, except for some very few types, side hinge doors, I can only think of two manufacturers that would make it, and they're both integrated hardware doors. They get expensive. That introduces the opportunity to put in bigger openings. So overhead coiling systems frequently, I won't say always, but very, very commonly are tested without an artificial bottom seal. I can think of at least one company out there that everything they do is tested without an artificial bottom seal. So you could go from the side hinge door here to a much wider opening. It's important to talk about this early, though, because shear walls are always right around those elevator shafts. So, but you can have a much more gracious, larger opening. And what happens when that thing closes? It stays closed. Nobody needs it. It's not on your egress path out of the building as a building occupant, and it's in no way in the way of the fire department in addressing the fire. Every fire department operation is always using the stair as their entry point to the floor. Now, that was a pretty straightforward example. We still identified a door that was not properly designated as tested without an artificial bottom seal. But that was a simple project. Let's look at something that's a little more complex. There's a lot going on in here, and it's a very common layout. If you look at this in the big picture, if you look at this in detail, it's a little more unique because it does have a fire service access elevator lobby on the right side. So what do we have here? Well, first of all, it's residential occupancy. It's an apartment or a condo. They're probably apartments. And apartments, residential occupancies, they're required by table 1020.2 to be enclosed with fire partitions, 1 hour fire rated partitions, or excuse me, rated fire partitions. Fire partitions are required to be smoke rated and fire rated, and all openings in fire partitions are required to be 20-minute S label. There is no requirement for tested without artificial bottom seal. So, for example, all of the doors leading into all of the units, those are all going to be 20-minute S label doors, every one of them. Zoom in a little bit. We're going to look at a couple different aspects of this fire service access elevator lobby. I wanted to point out some of those things because we'll come back to those in a moment. Let's look at egress and only at egress for the moment. So how do we get out of this building as a building occupant? Well, if you notice on the bottom end of that, there's that little short corridor that serves just a couple of units. I think it serves 3. And that's all it does. So there are 3 units in there. We maybe have, I don't know, 3,000 square feet. And with residential occupancy counts being at 200 gross, that takes us to about 15 occupants. And table 1006.2.1 requires that you only have to have 2 means of egress if you have 20 occupants. So that corridor down there, that little short corridor, having 1 means of egress is probably okay for the code. Now, would it be nicer to have 2 ways out? If I lived there, it would be. But it's not code compliant. With that in mind, if you look at the doors on the south end of the lobby, you'll notice that the door swings into the lobby from that space. And also swings out of the lobby from that space. It's a biparting door. So they were cognizant of the fact that they wanted people to be able to egress to get to the other stair through that lobby. Now, remember, any elevator lobby is permitted to be along your egress path. It's one of the few spaces through which you can egress on your way out of the building. So you can do that. Not sure that it's convenient or it's going to work well with the firefighters, but you could do that. The problem is not in that direction, though. The problem is in the other direction, though. So we only have 15 people there. So we could use that single way out without going through the elevator lobby. The other longer corridor cannot, though. We probably have 100 occupants in there, give or take, and they have to travel through the fire service access elevator lobby to get out of that space. So they have no choice but to do that. Now, keep that in mind. We're going to talk about some other issues, and these are going to all kind of merge together just a little bit. So let's look at the door ratings. Remember, we talked about multiple use fire assemblies. That means that if there are multiple requirements landing on one building element, you have to comply with both of those. So the corridor that we see on the north end, or on the south end for that matter, that corridor is constructed with 1 hour fire partitions. So the 1 hour fire partitions will be coincidental with the smoke barriers and the fire barriers that run through there. So those doors, because they are doors into or out of a fire-rated corridor required to be constructed with fire partitions, are required to have 20-minute UL10B and UL1784 doors. Exactly the same as every unit in that hallway. No difference. Because it's an opening in a fire partition. For the purposes of the elevator lobby, the fire service access elevator lobby, you're required to have 45-minute UL10B and UL1784 doors tested without an artificial bottom seal. So if we look just at the fire rating, 45 minutes is greater than the 20. If you have a 45-minute door, it covers both of those. And on the smoke side, if you have a UL1784 that's with no designation as to tested with or without an artificial bottom seal, then there's no way to tell whether or not we comply as a door for a fire service access elevator lobby. So we need to have that testing without an artificial bottom seal, and it will comply with both of those requirements. This is not a choice between the two. We're not picking the more restrictive. We're complying with both. They may recall that there was a requirement for direct access from the standpipe into the corridor. So let's go back, put our ratings back in there. And let's go ahead and properly rate our fire service access elevator lobby. And remember, in this case, they have that protected path. So far, this is fine. But we have our, actually, before we do that, look at this for a moment. And in thinking about the standpipe, consider whether or not this is code compliant and whether this does, in fact, work with the purposes that are expressed in the fire service access elevator lobby requirements. In the meantime, since it's connected to this, there's another side shoot on this. That elevator, that PE3, has a back door to it. It's for service. And it is permitted to have a normal conventional smoke rating on the back of that door, even though the front of it is into a fire service access elevator lobby. So that is a perfectly code compliant solution right there. Now, what is the problem that I was alluding to a moment ago? There's the standpipe. Does it have direct access into the corridor? Well, if you go straight down to the south and go into that corridor down below that serves those 3 or 4 units, yeah, it's fine. So it works down there, but doesn't work up there. The only way for that standpipe, a hose to go from that standpipe to that corridor on the top side of that drawing, is to go through the fire service access elevator lobby. That's specifically prohibited. So let's think about the things that don't work on this project. How about the rating of the doors in and out of the fire service access elevator lobby? If those are side hinge doors, the only solution is an integrated hardware door. However, in a lot of other cases, not when you're having egress going through it, but you, and in some cases you can, in fact, you can have overhead coiling fabric doors or steel doors for that matter. But the one thing that does not work is the is access from the standpipe to that north side corridor. Now, I point out all these little things, not to make fun of this project and not to tear it apart, but to make sure that we all understand just how complex these things can be. one thing bumps into another thing. It's like this then works. If there are 5 factors involved, maybe you can get 3 of them. 4 is tough, and getting all 5 is really hard. So this is a very difficult puzzle to solve. And the only way that I can see to solve this is to have a path that goes outside of that fire service access elevator lobby through which the fire department can drag their hoses. It'll also ease with egress, and you don't have to go through the lobby at all. So even though in this case, if you look at the entry into the elevator lobby, even though you could have some kind of a door system that potentially is side hinged, biparting, and is tested without an artificial bottom seal, it doesn't work for other reasons. So the real solution is going to be to have another path in addition to that goes back on one side or the other of this cluster of elements in the center. Now you don't have to have egress through the elevator lobby at all. So now what do? Well, you can keep those doors in there, well, if they comply. But you can use overhead coiling steel systems as well, overhead coiling fabric systems, which are smaller and lighter. There are a lot of different solutions that come into play with this. So just be careful of some of these subtle, nuanced problems that can really harpoon a good design. So just to go back just real quickly, understanding the purpose of the fire service access elevator is to get the fire department to the source of the fire quickly. We talked about the details on this space, on these spaces, adjacent spaces, coincidental spaces, understanding that multiple use fire assemblies is always in play. If there are multiple requirements landing on one element, it has to comply with both of those. So just be cognizant of that as you go through your projects. Separation requirements is a very unique space. Is the only place in the building that I can think of, and I've been looking for another one. I haven't been able to find one where you have a 45-minute door that has a requirement for an S label tested without an artificial bottom seal. And then we looked at a couple of examples of that. We hope you've gotten something out of this, and thank you for attending.
This concludes our AIA Continuing Education on-demand presentation. On behalf of SmokeGuard and the EBS Group, thank you for your time and attention. As a reminder, you'll need to complete a 10-question test to receive credit for this course. Simply click the test button below to get started. After completing and passing the test, you will receive your AIA Certificate of Completion by email to the address you provided before taking the test. If you're an AIA member and you provided your member number, we'll submit your credit directly to AIA on your behalf. Please allow up to 10 business days for your credit to appear on your AIA transcript. To recap, SmokeGuard's core offerings include standard and custom elevator smoke containment solutions and vertical, horizontal, and perimeter fire and smoke curtains. If you would like information on any of our products, design support, or additional AIA presentations, you can contact our support team or visit our website. Additionally, the EBS Group offers AIA-approved courses on life safety products. Balco covers expansion joints, photoluminescent egress systems, and fire stopping. SmokeGuard focuses on fire and smoke protection solutions, and Greco offers courses on commercial architectural railings and code compliance. Scan the QR codes or visit their websites to explore all available courses. If you have any questions or would like more information on SmokeGuard, visit our website at www.smokeguard.com. Thank you again for your time and interest. We look forward to seeing you on our next AIA On Demand video presentation.